Welcome back, and next up is Dave from the LoRa Alliance. He's going to tell you everything about the standard.
Good morning, good afternoon, good evening, and welcome to this discussion at the Things Conference on the LoRaWAN regional parameters, and specifically how we can use those definitions in order to implement global LoRaWAN solutions. My name is Dave Kjendal. I'm the CTO and Chief Operating Officer of Senet, one of the founding members of the LoRa Alliance, and a provider of public and private core network services, as well as a public operator in the United States. Inside the LoRa Alliance, I am the chair of the Regional Parameters Working Group on the LoRa Alliance Board of Directors, and I've been involved in multiple committees as well in the past. So we're very excited to talk to you today about some of the exciting work that is going on within the LoRa Alliance. Specifically, we're going to take a look at the regional parameter specification itself, specifically breaking it down into the two major kinds of channel plans that are defined there, dynamic channel plans and fixed channel plans, and how we can use that knowledge to implement very efficiently devices that are able to operate in multiple regions and multiple countries around the world. Then we're going to take a little bit of review around the changes of the specification that have occurred since the last Things Conference, and then a quick introduction to the work that we are currently doing within the committee today. So the regional parameter specification is a companion document to the Layer 2 specification. It sits in between the Layer 2 spec and the physical implementation of LoRaWAN on top of the different radio technologies that are available. So today in the specification, we have 3 different radio modulations that are defined. LoRa modulation, which everyone's very familiar with. Of course, FSK is also defined in the regions. And a new one that was recently introduced in the last version of the spec, LRFHSS, Long Range Frequency Hopping Spread Spectrum, also previously known as LoRa-E. We build channel plans that allow the LoRaWAN Layer 2 implementation to work inside of the different regulatory domains around the world, and that's what all these different channel plans are. These plans defines all kinds of interesting components or important components around channel width, maximum transmit power, dwell times, all kinds of different things like that, and we'll get into the way that you need to look at those requirements as you implement your devices. As we look at the channel plans and how they've been defined in the document, there really are 3 basic kinds of plans. 2 that fall into the dynamic channel plan category, and these are plans that have a very small number of default channels or joined channels. The rest of the channels are created dynamically after the device is on the network. And there's 2 groups. There's the 3 default channel groups, which was the original EU868 region, as well as Korea, India, and the original China version as well, of course, EU433 too. And then there's the 2 default channel regions, AS923 and the Russia plan. On the fixed channel plan side, we have 2 different groups over here. The 64+8 channel plans, and these are for the US 915 and the AU 915 regions, which is really all of the Americas. And then there's a 72 channel plan, up to 72 channels that are defined in the new version of the CN470 plan that was introduced about a year ago. So how does your end device actually end up with the correct and full set of channels supported by the network? The answer is it's a combination of things. Through the CF list, initial channel plans can be defined, so that happens as a response to the join process. But more importantly, ADR MAC commands, which enable the device to be dynamically provisioned by the network as RF conditions change, as the channel plans may change. In many of these regions, the actual set of channels that will be supporting your device is not necessarily known to the device when it joins the network, and it may change over time as different gateways with different capabilities are introduced, or as RF conditions changes, or if the device moves from one region to another region even within a single plan. So it's really important to look at that. ADR MAC commands are very, very important. Your device's support for ADR is very important for its efficient operation and its ability to operate with networks all over the world. As we look at the considerations that you'll have to take into account as you're looking to build a multi-region device, we have that broken down into really 2 different areas: the hardware considerations and the software considerations. So when we say multi-region device, what we're talking about is a device, a single SKU potentially, that can be deployed in several different LoRaWAN regions. What we're going to look at is across all of those regions that are defined today, they span frequency bands from 433 megahertz up to 930 megahertz. All of those bands are supported by any SX1261, 1262 base radio, as well as the new LR1110 radios. The vast majority of plans, with the exception of the EU 433 and the China plans, are between 863 and 930 megahertz, and these are all supported by the older radios, the SX1272 and SX1276 base radio designs. So on a hardware perspective, the radio chips themselves are already very, very flexible and allow you to have great agility across frequency bands to support these different regions. Of course, depending upon which regions you're going to support, you're going to need to look at the RF front-end design and your antenna choice to make sure that you have good efficiency across the bands that you're going to be operating in. On the software side, the key hint that we'll provide is that you really want to look at the similarity of these different channel plans that exist across the entire global definition. So again, those 3 channel plan regions, the 2 channel plan regions, the 64+8, and the CN470. That really defines the 4 banks of plans that will instruct your code on the general way at which it needs to operate across those regions. So it will start off in a very similar way. There are some differences around default RX2 channels, around how Class B works, various things like that. And we'll show you some tricks on how to make that very easy as well. Of course, that selection of regions, so if you build a single SKU that's going to operate in many different regions, you'll need to select that region. That can be selected at time of manufacture. It could be selected during a configuration to order step at distribution, or it could even be manually configured by the end user. We're not going to talk about over-the-air configuration right now. That is one of our topics for future consideration in the group, but it's out of scope for this discussion because it is much more complex than a device that stays within region once it is initially deployed and configured. Both the LoRaWAN Layer 2 spec 1.04 just released, as well as regional parameters 1.02 again just released, have both simplified and clarified the specification to make it clearer and easier for you to implement these multi-region devices. So I strongly suggest you take a look at those new specifications. One of the things that we added to the regional parameters specification was these quick reference tables. So these quick reference tables will give you at a glance all of the important default configurations of all the different regions. We're looking here at the dynamic channel plan regions. There's another table for the fixed channel plan regions. But this will give you those configuration differences between each one of those regions that now allow you to build a common set of code that again handles your 3 channel plan regions, your 2 channel plan regions, your 64+8, and the China region very, very simply. When you're moving on from that basic side, there's a couple of things that I want to remind everyone about. First is that the LoRaWAN specifications are written to help you remain compliant within each region. They do that by setting appropriate defaults and defining maximum payload sizes, spreading factors that are available, which default channels are defined, the channel widths, the maximum transmit power. All of these choices were made to make it as easy as possible for your device to remain compliant within a region. However, in addition to the regions that the LoRaWAN specifications define, each country has its own regulations which must be complied with. Now, sometimes that's a group of countries, like within Europe, ETSI specifications. However, you need to look at those requirements within the country and make sure that your device will be compliant with that. In addition, many countries also require certified test results in order to get your stamp of certified approval to operate. Some of the things to take a look, keep an eye out for are any things that may not be defined in the LoRaWAN specifications, are things like listen before talk, which is important to operate in Japan, for example. Dwell time limitations, that's how long the device can continuously transmit on a single channel for. Duty cycle limitations, this is a measure of how much on-air time over a long period of time the device is going to consume. Transmit power measurements, there's several different variations of these that vary from region to region, and even antenna gain limitations as well. So please take a look at all of those. Make sure your device is compliant within the country that it will be deployed in. At the end of the day, it's the responsibility of the hardware manufacturer for end devices and gateways to gain regulatory approval for compliant operation of their devices and to guarantee that that device never operates out of compliance within the country that it's deployed in. So again, please take that very seriously and take a look at that. One of the things that confuses people in some cases is that the LoRa Alliance has defined these regions that span multiple countries. AS923 is a good example. It covers hundreds of countries. However, that plan was created that way to make it easier to implement a solution. It doesn't remove from the responsibility of the hardware manufacturer for actually making sure that it is operating compliantly within each of the different countries and making sure that it stays compliant while it is in operation. So again, please keep those things in mind as you're implementing your solutions. Taking a look at the work that's been done by the working group since the last Things conference. We did publish 1.01. We talked about that at the last conference. It was published in February. It includes the significant flexibility for the AS923 style plans. Basically, we took the original plan and we created 2 additional plans that simply offset it in frequency. AS923-2 offsets it by 1.8 megahertz to cover Indonesia and Vietnam. AS923-3 offset by 6.6 megahertz to cover many EU and EU regulatory style countries, as well as Cuba and Philippines. And CN470, which was released in 1.0, was also updated based on the most recent regulatory guidance out of China. 1.02 was just published in December of 2020. It defines this new long-range frequency hopping spread spectrum, previously known as LoRa-E data rates, for US 915, EU 868, and AU 915 regions. Really, this is targeted at improving some performance in a couple of different areas. One, it's very important for satellite communications. The second one is in the EU regions. It does significantly increase the capacity of the gateways. Remember, those gateways are typically 8 or 16 channel gateways, so a little bit more capacity constrained than they are in the US or the Australian regions. In the US 915 and AU 915 regions, this allows for an improved maximum payload length at the best propagation in these areas. And that is to comply with the 400 millisecond dwell time while still having that SF10 kind of equivalent propagation using LRFHSS. Additional countries were supported, as always, and those quick reference tables were added for the regional summaries as well. As we move forward into 2021, we do anticipate a new version of the specification to be released relatively quickly to align with recent regulatory decisions in Israel. So that will most likely look like an AS923-4 plan, but again, a shifting of the AS923 plan to accommodate the new spectrum that has recently been opened up for us in Israel. And then as we start looking at more creative things that the group is doing, one of these areas is directly in line with what we talked about during this talk here, which is the ability to support multi-region devices, but taking it to the next step to support devices that are mobile through multiple regions. Again, so this is something that we're looking to be able to offer as pieces of a specification, that again, that guidance, the help, and the tools that enable you to become compliant in those regions. We're also looking at adding some additional flexibility into, and both of these two are in collaboration with the layer 2 specification work, to dynamically add additional unlicensed bands to the fixed channel plan regions, and to do that very efficiently and flexibly. And then also we recognize that we're going to need to change the way that we define data rates. Data rates today are fixed definitions inside of the specification. We've run out of available data rates in the 3 regions that we just defined for LRFHSS. So we're going to need a new way to configure data rates as new modulations, new bands, new channels are made available. So keep an eye out for that work that's coming out this year. And then finally, I would like to encourage everyone to tell us about your successes. So we'd love to hear about the deployments that you're doing. I'd love to hear about the certifications that you've gotten within different countries, for sure, as well as with the LoRaWAN certification. We have about 50 countries, yes, that we're slowly kind of working through. You can see them in gray on this map. Everything else has a channel plan defined. what we really need is your help to bring attention to those regions, those countries that need our attention and need new plans. So with that, I'd like to thank you all. Have a good day and have a great conference, and talk to you next year. Cheers.